It's good to have you in one of our math lessons. In this lesson, we'll be learning integers, rational and irrational numbers. You would need a calculator, a pencil, worksheet, exercise book, or paper. Keywords. In this class, you will hear words like this: rational numbers, of course. A rational number is a set of numbers that can be expressed as fractions. That is, as quotient of two integers. Now, that is where you have one number at the top called the numerator and another at the bottom called the denominator, as this case. And we also have examples of non-rational numbers. One of them is this, which is called pi. Averagely, pi is 3.14, and then we have the square root of 2. These are irrational numbers. Why? Because they cannot be expressed as fractions. Commutative law. Now, when we talk about the commutative law, operations are commutative if the order in which terms are given does not affect the result. For example, if I say A plus B, it's the same as B plus A. And BA is the same as AB. AC is the same as CA. That's how it works. Now let's look at examples. If I say 7 plus 4, I could also say 4 plus 7. I'll get the same thing, which is 11. If I say 5 times 3, I'm going to get 15. If I say 3 times 5, I'm still going to get 15. But this doesn't work with subtraction and division. For example, if I say 6 minus 2, it's not the same as 2 minus 6. And if I say 12 divided by 4, it doesn't mean the same thing as 4 divided by 12. 12 divided by 4 is 3, but 4 divided by 12 is 1 over 3. Associative law. The associative laws are about grouping. Now, the order in which you add or multiply does not matter. Now, look at the first example. Look at this. 6 plus open bracket 4 plus 5 close bracket. Now, I can change this to 5 plus 6 first before I add the 4. Or I can say 6 plus 4 before I add the 5. I will still get the same correct answer. I could say 2 times open bracket 3 times 4 close bracket. Now I can decide to just first multiply 2 and 4 and say 2 times 4 I get 8 before I say times 3, and I'll get the same correct answer as if I do 3 times 4 before times 2. Is that so? Do you get that? Smart one. Now let's look at non-examples. It doesn't work again with subtraction and division. You can't do the same thing. You can't just put the numbers and say, oh, if I say 3 minus 6, if I decide to change the order, I'm going to get the same thing. No, you will not. When it comes to subtraction